Hi, my name is Mia. I hope you are doing great. I'm on vacation right now, and I decided to come to this beautiful place. I love Brazil. I'm wondering, have you heard about pi? Well, circles make no sense without pi. Trigonometric ratios also use pi. These components may not directly be used, but are used extensively in engineering. They revolve on designing things for real life and several things like signal processing, force calculations, speedometer, etc. The value of pi is approximately calculated to over 22 trillion digits without an end, so pi is an irrational number. Interesting, right? Well, let's start with the concept of rational and irrational numbers. A rational number can be written as a ratio of two integers, for example a simple fraction. An irrational number is a real number that cannot be written as a simple fraction. In here 1.5 is rational, but pi is irrational. Pi is a famous irrational number. We cannot write down a simple fraction that equals pi. So, if you think about it, we can tell if a number is rational or irrational by trying to write it as a simple fraction. For example, 9.5 can be written as a simple fraction like this. So, it is a rational number. Let's look at the square root of 2 more closely. Square root of 2 is equal to this expression. But it is not a number like 5, or 5/3, or anything like that. In fact, we cannot write the square root of 2 using a ratio of two numbers. So, we know it is an irrational number. We can also represent irrational numbers on the number line. We do this by understanding that irrational numbers are unique in that they cannot be expressed fully as fractions, but they can be visualized on a number line with rational numbers by using approximations. Is the number 2 pi a rational or irrational number? Represent this value using a number line. As you already know, 2 pi is an irrational number. Additionally, the value 2 pi is equal to 6.28318, etc. And it sits between 6 and 7. Now let's talk about rational exponents. Rational exponents are exponents of numbers that are expressed as rational numbers, that is, in a to the power of p over q, a is the base, and p over q is the rational exponent. Where q is different than 0. In rational exponents, the base must be a positive integer. Rational exponents can also be written as x to the power of m over n, and this expression is equal to the n root of x to the power of m. Let us go through some formulas of the rational exponents which are used to solve various algebraic problems. The formulas of integer exponents hold true for the rational exponents as well. Consider rational exponents with same bases, a to the power of m over n, a to the power of p over q, and a different base, b to the power of m over n. I'll give you a moment so you can analyze them. Now, let's simplify the following rational exponent. Here we have 64 to the power of 2/3. It is easier to determine the cube root of 64, and then squaring it as compared to finding the square of 64. Let's finalize by finding its cube root. So, if we want to simplify the rational exponent 64 to the power of 2/3, we have this. Remember that the cube root of 64 is 4, and 4 to the power of 2 is 16. So, this rational exponent is simplified to 16. Cool, right? So, what do you say? Can you continue recognizing rational and irrational numbers in real-world situations? Just remember that today you learned the concepts and characteristics of rational and irrational numbers. How to differentiate rational numbers and irrational numbers. And how to apply the properties of integer exponents to generate equivalent numerical expressions. Practice a lot, and you will see that you will be better at it. I have to go now. Bye. And see you next time.